The last class, we spoke about functions in the last class, and we described how functions in mathematics will affect the LHS with respect to the RHS, right? We took an example of y equal to x, and x was varying equally, y was varying. Okay. Then we say it is having a linear progression with respect to the LHS, RHS. Then we change the RHS with the x plus 3. Then the y is changing 3 times more with the change of the x value. Right? We saw that thing. And we also discussed about vector. We mentioned that it is in vector can be described in two different fields differently. Okay. As I was telling you, in physics, we draw an arrow and we say from B to Harvard. So B is one point, Harvard is another point. We have decided the direction from B to Harvard is from B. The direction is there, and the distance is 20 kilometers. 20 is the value. Direction is towards the Harvard. Okay. So vector is having direction and the value that is holding it. Alright. So we define it like vector is a quantity which has magnitude as well as direction. Alright. You study this in unit and dimensions in physics, where we will be looking at this one as having quantity as well as the direction. And we saw an example of force having the vector. We have given an example of some Newton of force that you are applying on an object, and you have a direction of force that you are applying. Alright. So that will be one of the examples of vector in terms of physics domain. Same thing if you tell it in mathematics, then we can represent the vector in terms of matrix. Okay. That's how it is changed with respect to different domains that we go. But the meaning is same. It is the dimension which is being represented in mathematics in 3 dimensions. Alright. So we have 3 dimensions, that is 3D. Okay. We have x axis, we have y axis, we have z axis which is coming out of the plane. Alright. That board, the whiteboard is a 2-dimensional one, and if anything is coming out of that board, it is z axis. Alright. And that's what all the x, y, and z can become vector, and we can have the values among them, the range of them. Alright. That's what we discussed yesterday. That's one of the important unit in your AI as well as machine learning, which is going to represent the data in 3D space, and that data will be represented in terms of text as a matrix. Alright, one arrow, a diagonal arrow, is represented in mathematics with respect to a matrix. As you draw a square matrix and write numbers in that. That's how we represent the vector in terms of. We discussed about the linear algebra is concerned with the vector spaces, vector 3D spaces, vectors and linear functions. Understand what is geometry and what it deals with. What it deals with? Geometry basically deals with what? What it deals with?
It deals with measuring the sizes, areas of objects.
Okay. Points. So points, selection of points makes lines. Selection of arrangement of lines makes objects, figures. So study of shapes. Alright. Study of shapes can be geometry. You can define another way also. Functional analysis. Functional analysis. How will you understand this? Behavior of functions. Okay, when you take multiple equations, how you solve the multiple equation with each other, helping each other, and you also analyze how they are behaving with the different values that have been added to that. So that's the analysis that you are doing. That is with respect to your linear algebra. The branch of mathematics that deals with the vectors, matrices, finite and infinite dimensions, as well as linear mappings between such as spaces is defined as linear algebra. Between such spaces is defined as a linear mapping between such spaces. Which are spaces? Vectors, matrices, finite or infinite dimensions. I hope you understand the words vectors, matrices, matrix, finite and infinite dimensions. I hope you understand what is this one. You understand this? What is the English meaning of dimensions? Sizes. Okay. Okay. Anybody else? Any other meaning?
It's like this.
Yes. Okay. Finite or infinite dimensions. We have. You also say 3D. What is D? I have this board, length and width. What are these? What are those? Height and width are dimensions. Are dimensions of your mechanical object, right?
So they define the area, shape, volume of the object.
Okay. So they define the dimensions, basically. They are the parameters of any object that you use to measure. All right. They are units you are measuring. So those dimensions may be finite or infinite. So mapping between them is the study of linear algebra we are saying. Okay. We are trying to measure the matrices and different finite or infinite dimensions in the vector space. We'll be going to study that with the help of linear algebra. Okay. I hope we studied in the last class how linear algebra can be plotted on the graph and can be understood with respect to different values. If I take a small function and try to prove that in the graph. Okay. So what it says, it is used in both pure and applied mathematics. Both pure mathematics, that is core mathematics, and application of mathematics, along with the different technical forms such as physics. You have engineering, you have natural sciences, we understand physics, then engineering, then natural sciences. These are the applied branches of mathematics. You understand that? How is this? Branches of linear algebra that can be categorized into depending on the levels of difficulty and the kind of topic. Elementary, advanced, and applied linear algebra. Elementary linear algebra, advanced linear algebra, and applied linear algebra. So there are different types of linear algebra that we should be studying. Each branch covers a different aspect of matrix, again, vectors, and definitely linear functions. All these three will together work whenever you try to analyze one of the model in machine learning. Alright. I hope you understand the vector in terms of matrices. We have a small example. A vector is a data structure with at least two components, that is magnitude and direction. And this will be it's the most commonly used machine learning to represent data in the most optimized at what we already said. This could be scalar having only direction, magnitude, having only magnitude is scalar. Temperature is scalar or vector?
Scalar.
Scalar. Okay. Pressure is scalar or vector? Force vector. Pushing on some object with some direction, obviously. Without direction, I cannot push it. Okay. Temperature doesn't have direction, right? We cannot tell it in the direction. Only value is much temperature. That is a scalar. Okay. This will be our vector. It will be our vector. We have one as and we have a matrix. This is how the matrix look like. It can be a matrix with one also. I can make it. That will be 1 cross 1 matrix. So this is 2 cross 1 matrix. And this will be tensor. Tensor is again another data structure where it is storing multiple matrices or multiple vectors. And the process
These all are the mathematical concepts. Tensor, scalar. These are basically fundamental math concepts.
It is the basics.
I thought that the name of the data science area is today.
They're basically okay. Those are from non-technical background. You need to go back to your 10th standard and recall it. Alright?
Because there is a tensor flow and there is a scalar.
Yes. Yes. There will be basic mathematical concept. Just trying to understand basically and trying to conceptualize it in terms of our next usage of this thing, where we can use it. Okay, whenever you use vectors in terms of tensors, you need to use the TensorFlow libraries to process them, and they will be one of the data available in 3-dimensional spaces, and they will process your matrices in terms of 3-dimensional data, but in terms of matrix, they will be 2-dimensional data, x and y. Okay. Understood. We have other vectors, but if you can understand, we can take the 3D diagrams. Else, I think you can understand that. This is physics. Okay, physics. Okay. Okay, you get confused with this one. The 3-dimensional plot, they will have a x, y, z, all the 3 planes available, and the data is spread, and they just made some angles for a specific object to point to. Okay. Okay. Elementary linear algebra, as we just saw, some of the scalar matrices and tensors. Let's study them as a definition. Scalar is a quantity that only has a magnitude and not direction. As we are saying, it is an element that is used to define a vector space. And we are saying in linear algebra, scalars are usually a real number. So what is real number? We studied in basic Python. Real numbers. Real numbers. Okay.
Which are not complex.
Okay. Simple numbers. They are real numbers. There are also fake numbers. They are saying real numbers.
It includes integers and fraction numbers.
Okay. Real numbers are floating point values. Okay. Okay. We are making a statement here. In linear algebra, scalars are usually real numbers. Okay. In terms of real number, we also can say in counterpart as imaginary numbers. Okay. Real parts, imaginary parts. We also have a complex number as I said. Remember? Okay. J values are there with a plus in basic Python we are studying. Okay, how about vector? As we just saw, vector was represented in terms of matrix. So let's see what it says. Vector is an element in vector space. It is a quantity that can describe both. It is a quantity that can describe both the directions and magnitude. Okay. It is quantity itself. It is one of the measuring quantity itself at one of the dimension that says or that tell you the direction as well as magnitude of an element. Okay. I hope you understand the scalar and vector. No problem. In terms of matrix, one matrix holding two values having a direction as well as magnitude will represent one matrix as a one vector. Okay. A number which is holding as one as a magnitude could also be said as one of the scalar primes. What does it mean vector space? This is very important keyword as we're taking it as a glossary or dictionary. We're just preparing in your mind so that you can understand whatever explanation we do in the next class. You understand what is vector now in terms of as well as in terms of physics, the direction. Okay. Now, what we are saying, the vector spaces consist of vectors that may be added together or multiplied by scalars. Scalars means their vector magnitude could be multiplied or they may be added. All right. So that's what we can do as the operations on the vectors. All right. How could you define displacement? Do you understand keyword called displacement? Divide 10 meters. Yes.
It is moved by 10 meters.
Moved by 10 meters.
So displacement. Okay. It moved forward by 10 seconds. 10 meters.
That's it. That's how we can define.
Yeah, displacement. If I write down this here, then okay. If I move it from here to here, it will displace by 2 seconds.
Okay, that's right. In terms of vector, as we are saying, in a vector space, we say these vector spaces consist of vectors that may be added. Vectors may be added or multiplied. Yes. Okay. I wanted to reach, this is the 2, this is 4, and this is my direction. And I wanted to reach from this point to this point. I'm reaching this space. Okay. How can I add these two vectors and how can I reach here? How can you define a displacement here? Shortest path we can take it. This is what your displacement is. that right? The distance that you have traveled is this one and reached at this place. But your displacement, if I say, you actually, if there were no obstacles in between, you would have directly went from here only. Because of obstacles are there, you took the different way. Okay? Your start source and your destination are constant, whatever path you take. All right. In vector space, that's how the vectors could be added, and it will make your expressions look simple by making those vectors one. That's what it is saying, making the adding two vectors, and also it is multiplying two vectors. Vector A, vector B could be two vectors having their own values, and they could be multiplied as two vectors. Okay. Let's see one example and let's understand. Have you learned vector addition, multiplication in physics? Ready? Okay, quickly analyze this and let me know what you can observe in this one. The top arrow is vector. Okay, above that there is small arrow. That's vector representation of the quantity. Now just observe that and see what you find. Different colors are there, and there are some values.
Typically adding that. If the length of yellow is 2 and length of this is 3, sir. Or this is 3 and that is 4, sir. Then that should become 7, sir. Algebraically adding both of them. But adding geometrically, that will be 5.
That will be 5. Can you tell me? I'll write those numbers there.
Yes.
Please tell me.
Length of yellow line is 3, sir.
Yellow line, this one is 3?
Yeah, this one is 3.
Okay.
And height of red line is 4, sir.
This is 4?
Yeah, height is 4, sir. So, blue line, adding them together, blue line and length should be 7, sir.
Length should be this one?
7. Yeah, that should be 7, sir.
This should be 7.
Yeah, by adding algebraically, that should be 7.
Okay.
The distance between the endpoints is only, that will be only 5, sir. Adding geometrically. Now adding vector wise, that will be 5. That was written in the last.
Which one is 5? A.
Yes,
only A.
Blue A will be 5, sir.
Blue A will be 5.
Yes, sir.
How?
What is the Pythagoras?
Pythagoras theorem says?
Because that was written in the last slide, sir.
Okay. Tell me the Pythagoras theorem. I want to use these quantities as he's telling.
How you write here, sir? On the back of this.
Okay. Yeah, this will be very good.
Ordinarily checking.
A square.
B square plus y equal to 5.
Square is A and here is C.
Suppose the name is A.
A because here A is B.
H square equal to B square plus C square.
B C square.
Make A value this square.
AB is 3.
Square plus B square. Multiply
9. 25.
and A square. Square root of 25 is 5.
So with that, it makes a vector as 5. Okay. So with this one,
Sir, but this one and this one is not matching.
what is not matching? We just scored with respect to the triangle.
Here
Okay.
you are A equal to AB plus A.
This is not the Pythagorean theorem. This is the what you can say vector addition, where we actually add those values. What is the meaning of that? Then let's understand. So it says vector x says the vector A moves from 0 till this point, okay, and from here it is going to move this place, okay. That's why the direction is like this. This is the behind that there is an arrow. You can see this is the arrow, and this is another journey of that point. Now the points ended there, okay. We wanted to find out the displacement. That the direction is the long. You wanted shortly tell, like as you said, you just shorted it. Shorted is the shortest distance. We're trying to find out. That's what the vector addition is. Okay, in terms of geometric, we can say that we are having the dimensions. Both the dimensions to be merged and say that this is the displacement, final displacement. Okay. So we wanted to speak about displacement in terms of the vectors. In vectors addition, that is the same thing that you're doing there. Take one more example. Yes, definitely. Look at this example. 11 kilometer north, 11 kilometer east. It is traveling. When you add them, what is the resultant value that will be getting? That is a resultant value that we just now did. This is 11 square, 11 plus 11 square, and you are going to make it what is the answer? 11 square is 121. 121 plus 121, 242. Square of 242, it's 15.6. And the R that we have called 15.6. Maybe like this. Is it right? Same thing if I draw it there, will it be right? Yes.
I think we can have this exercise. A person starts working from one day, and he comes to be 1 kilometer. Comes to see 1 kilometer. 1 kilometer by sound. Comes to be move 1 kilometer from here to here. Only 1 kilometer. Zero displacement. But we have got 4 kilometers. We have got 4 kilometers, but displacement is 0. And displacement is the vector. Anyway, we can answer. So this I think is clear. I think we will see example with this.
If you understand this, I think they are
Actually,
same
we go with this and we can have this one.
section problem.
Yes,
Vector.
Because the displacement is everywhere 0.
Okay, yes. You will not be having the directions in traveling section. We will have a quantities there. Quantity with the multiple directions. You can't take it directly with that. Okay, can you tell me this one? We'll take one more example after this. Quickly tell me this. Okay, we'll take it inverted. This is 11. and if this one so the end is 11 itself. This is not this south actually. This southern, this eastern. Okay. Okay. So if I say this is 11 points in terms of graph, if I am saying some XY axis, 11 points, and from here we have 11 points. And how about this value, R value? In what sense? The total displacement.
This 20 kilometer is the distance. 22 is the distance. 15 is the
Displacement. Vector is trying to add it and telling you that this is the shortest place. You understand that? As such, from A, point A, you started your journey. You came at B, okay, 1 kilometer, and again you started your journey towards this direction. This is your C. At this point you stop, and again you change your direction. You came at D, and again you end up coming back to A. Now the question is, what is the value of displacement? Okay. Alright. Yeah. We started from A, B, C, D. Go back to A. What is the displacement value?
0.
Right.
Yes.
Okay. How about distance he covered? 1 kilometer. This is 1 kilometer. 1 kilometer. 4 kilometer he traveled. Displacement is 0 only. Right? This will be one of your aptitude test. They will not give the simple square box. They will twist it somewhere else. This way they will give you. And they will give you all these distances. All these dimensions they will give it. And then they'll ask you from A to B. This is the place, all the places we have visited. So what is the maximum displacement we have done? Such problems will be there in your interviews. That you need to understand meaningfully. That is displacement is from A to how far I have went. Your airplanes give you the actual feeling of that thing. They don't have the roads, they have airways, which are not having the obstacles, so that they can change the direction and go. But they have the airways which has been defined for various specific place. But obviously they have the displacement for some point. They make it a straight direction from A to B. They directly reach. They don't have the via options. Right? That's what the displacement is. Got it? We call this property as cumulative property. In books of mathematics, you might have heard of this word called cumulative. Okay, commutative, associative, rules, distributive. You have already the rules, right? So here we are talking about a commutative property, which says A plus B therefore vector quantity is equal to B plus A, which is same. RH is equal to LHS. Okay. Triangle of addition. Triangle of addition, as you did. Consider a vector given in a figure. The line PQ represents the vector P. PQ represents the vector A. QR represents the vector B. PR. The line QR represents the resultant vector. The direction of AC is from A to C. The line AC represents vector P and vector Q. Vector P and vector Q. The magnitude of the resultant vector, magnitude, the number of the vectors, vector is given by what is this symbol? Yes. So why do we have that? Okay, then we can remove that.
So remove the negative element.
Remove the negative value and consider only positive values. Right. Okay. P whole square plus Q square plus 2PQ cos theta is the equation that they have taken to find out the magnitude of the vector. This you will see in physics. The resultant formula in terms of physics. They have taken cos theta because they have the angle being made in the triangle, the vector classes. They have made an angle. That angle they are using to find out the resultant. Okay? Because they wanted to check how the resultant vector is tilted, how much tilted? The R, I mean the resultant one. This one is how much tilted. They're just trying to check that. That's why they have taken cos theta. I hope you understand what is cos theta. Go to the board and tell you what is cos theta for 2 minutes. Okay. Okay, this is my A, this is B, this is C. Okay, we wanted to designate each of the sides. So, what will be this side? Opposite side. In terms of graph, it is definitely Y. In terms of our trigonometry, we call it as opposite side, adjacent side. We call it adjacent side. Hypotenuse or resultant. You can remember resultant, but tell it as hypotenuse. Fine. Now, the question is, why are we writing like this and what does all those mean? We are talking about the angles. For example, first one we will take it is this one. If I want to mention this part, then I will use the help of this one. Then I will say opposite side divided by adjacent side. For example, if I want to mention this angle that has been made, I will take the help of these two. Obviously, both are actually making angle. That's why I should consider these and this must be as one of the values. Agree? So for that, I will take them as adjacent side by and whenever I want this angle, I will be taking opposite side and hypotenuse as two of the vectors who are making the angle. Okay. This is it's not possible. Hypotenuse. Okay. So we are talking about this one. That is this one. Where is this? This is the diagram we have in this one, right? Same diagram. We have this part. This part. So that's the resultant. Making some angle with the base. That's what we want. Same thing if you compare here. This is what the angle, correct? And which is made by this line and this line. This both things we need to consider. All right. When I consider both the things, this is my equation. All right. This is the one. So this we call it as this. All right. That's what we are trying to make different quantities. So this I am calling it as cos, angle that will be made by the resultant one at the base. This we are going to call it as yes, tan. This side. Okay, just given this theta and these two sides has one name, cos angle. All right. That's why. So all the thetas, if I add, what will be the resultant total theta? 180. Okay. So we how much?
3 theta is equal to 180.
3
Theta equal to 180.
3 theta equal to 180. Okay. This one will be probably 45. 45, 90. That is totally 100. So totally it is 180. Okay. So that is how you can say that if you open that and say how much it is going to open. So you can open in a single line and you can have 180 degree of angle. Okay, you cannot go down of that. So that's one of the minus angles, other angles. But if you open that whole thing and say that becomes a straight line having the 180 degree. Understood this one? So that's why we have taken a cos here with a 2 PQ cos theta. Cos theta is one of the angle that has been formed in the triangle, and using that angle we are trying to understand what is the angle created with the, this vector, and with that we are able to find out the resultant vector. All right. In terms of physics, it is different. We'll not go into physics presently. We'll speak on to mathematics. Theta represents the angle between the two vectors. Let the phi be the angle made by the resultant. So tan phi have q divided by p plus q sin theta. Will be the tan. So what will be the tan there? Opposite side by adjacent side. So that both of them. That is sin by cos. Can it be sin by cos?
Sin by cos is tan.
Sin by cos can be tan? Yes. When somebody says yes, and if they won't answer, those who don't understand, tell me to tell again. Okay? When 2 people say yes, sir. Other people have not answered that question, that means they have doubt. If they don't have any questions, then they can stay silent. If you have questions, you can just tell, or you can just have a rough mind, just try to, if you are indicated, I will be able to explain it. Figure indication. Okay. Multiplying a vector. Vectors can be multiplied by each other, but they cannot be divided. Only can be multiplied. Okay, let's understand dot product. We have two vectors, vector A, vector B. Scalar product of these vectors could be vector A, vector B, and cos theta. This angle between the two vectors is vector A, vector B, and this is the vector, the resultant vector. We have C equal to A cross B. Dot product. Dot is symbol cross product or multiplication. This is again the minus C equal to B cross A. That's what this mean about. This is your C. This is A and B. How do you represent it? A equal to A1I plus A2J plus A3K, and B equal to plus B vector equal to B1I, B2J, and B3K. In this case, the dot product is given by A1 dot B1I plus A2 dot B2J plus A3 dot B3. So there are two equations and you are trying to multiply them. And that's what each quantity is being multiplied and will be added. And that you can do it with the help of this formula also. The vector A and vector B. These product of two vectors can be denoted like this, and you can write the equation like this: A vector and vector B sin B. In addition derivation, how do you multiply two matrices? You multiply like this only. And when you multiply, you not only multiply, you add the next quantities. Okay? Can you tell me one example I did there? If you just tell me one example. Tell me the rules of multiplication. Do you have the rules for mathematics multiplication matrix? Okay. Can I multiply
both C should be same.
C should be
Same between both. This is 1 into 3, sir.
row 1 into column
R2 into C2.
1, R2 into
C2.
C2.
C should be
Now column
C should be common in both. Then only it can be multiplied.
how many is equal?
9. This is
C1 equal to
C2. C2. Then only multiplication can happen.
means the column must be same.
Column of the same. This is 1 into 3. That is 3 into 1. So
So
multiplication.
how many columns are there?
1 into 3. This is 1 into 1 plus 3 columns.
No, according to this one.
3 columns. 1 column.
That's all. One column, one column.
Yeah.
This is the condition.
Yes, sir.
Okay, can you multiply? 2 into 2.
2 into 3 plus 2 into 3 plus 2 into 4.
Then
Then 3 into 3 into 4 into 2 plus 4 into 3 plus 4 into 4.
okay, can I write the different matrix here? Is condition is right?
Confirm it once.
Sir, 4 and 6.
No, just tell me simply, how do you hear about that? Graphically, we'll use the arrows and you just understand how we multiply. These things you multiply with this one. Okay. So in that case, I need to have this one row matching with these numbers. Okay. That means the number of columns must be equal to. Okay. So this is my R2 must be equal to this is what? This is row, right?
Yes, sir.
This is column. Tell me. You tell me how should I modify? Okay. I should write R1 here.
No, sir. Column. We are taking the column values.
Column value.
Here we are taking the row value. Each one row value.
I am talking about this one.
Yes, correct.
R1. R1 is here. R1 should write it. Okay, tell me R1 equal to R1. These are matrix 2. This one I am taking. Matrix from matrix 2. I just wrote here, right? Same thing. Okay. These values I'm taking. You getting confused? Or I am getting confused? This is row 1, correct? Exactly correct. This is 1, this is 2, this is 3. Agree.
So you create two matrices with the simple values. First matrix, one matrix with
Okay, 2 cross 2 will create
1,
2, 3, 4, 5. Here also same numbers. Easy multiplication. 2 into 2, 3 into 4. That means these numbers you are trying to multiply with these numbers. Okay. Now, if you don't have to worry if these two numbers and these two numbers are not existing. Do you worry? No. So still you can make calculations. That's what we are trying to understand here. That how many columns here are here? 2 columns. 2 columns. Here 2 columns. 2 rows here. What you are getting confused and what I am getting confused with this one.
so you are correct and nobody is getting confused.
No, she is saying something. R1 should right? Okay, with that, what will be the message that you are trying to convey? Even if this is my first row. 2 and 3 first row. Okay. How about this one? This is my column. Column value it is not a. It is subscript actually. Don't consider this given. This is not. You are talking about R1 row. No, there is not row 1. This is subscript. Okay. I am talking about this as this one only. Okay. Have you understand? Okay. I hope you understand 2 into 2. After this, what should I add? Should I write plus? Plus I should add. Then 3 into 4. Then that's it. So you add the number, you get 16, and there will be a resultant matrix. Okay. So that's what it is trying to have, multiplication of matrices. So I hope the rule is clear. The number of columns in the first matrix must be equal to the number of rows in the second column, second matrix must be equal. Whenever you do the matrix program also, you have to consider this condition while writing the program, else the program go wrong. Getting? Firstly, in your program, you should ask the rows and columns. If they mention different number with respect to C1 and R1, then you should raise an error. No, you are doing somewhere mistake. So you please mention a C1 and R1 same number exact. If you are told in the first C1 10, you tell me R1, I have considered already R1 is 10 only. No change. Get it? Alright. I hope this is also very clear. This is made those stated and just trying to multiply those numbers. They are making it very fast. I think not able to observe. This column they are trying to multiply with all of them one time. So where is that? Another one. Okay. The matrices and the values that you are getting are looking simple, but they are so much important. If you understand it, it is very important concept that you understood. Okay. I'll just tell you in a small 1 minute. I'll just tell you why it is important, what you learned. You actually learn how to compress and photo with this matrix. That's a small example. If you understand that, you already understood how the photo will get compressed. Resolution getting smaller. Your WhatsApp, if you send a photo, its resolution go down. Here it is. It is reducing your photo by some resolution by making by using all those two values from one matrix and the two matrix and another value from next matrix. They are merging that thing and making it as one value. Okay. If you zoom it, you have square boxes of colors, different colors, right? And those adjacent values get merged, and two boxes of color values get merged and become one value. That means your bigger photo, like 10 by 10 matrix, merged into 5 cross 5. Because two boxes get merged and become one. Okay? So 5 cross 10 photo becomes 5 cross 5. Then your photo becomes small, and if you try to zoom it, you see the blurriness of this thing. Even if you want to reduce it, again make those boxes, when you zoom it, those boxes are still merged, and make it again 3 by 3 or 2 by 2. Very small photo and blur. Okay? Similarly, if you want to enhance, old photo is there, a very blur photo is there, I want to enhance it. This I want to make it. Then also again the reverse process. You add some values into that, calculated values, and you find the edges in the photo, and then you enhance those edges by adding some more value to that. And your photo becomes larger and larger, and you can see the clear photo. Okay? That's what matrix is so much used in the OpenCV library, mostly. Alright? That's how your